The device in your pocket feels smooth, it feels seamless. It feels like a single unified object conjured from the future. But this illusion of simplicity hides a complex and profoundly global story. It's a story that begins not in a clean, brightly lit lab in California, but deep within the Earth's crust, scattered across continents. The journey of an iPhone starts with the gritty, arduous work of mining. It's born from rocks and minerals, extracted from the ground in places thousands of miles apart. This initial step is the foundation of everything, the raw, elemental beginning for a device that will one day connect millions of people. It's a process that touches countless hands long before the first circuit is ever etched. To build an iPhone, you have to first gather a specific cocktail of the planet's elements. From the Democratic Republic of Congo, miners extract cobalt and coltan. Cobalt is essential for the lithium-ion batteries that power the device through the day. Coltan is refined into tantalum, a crucial metal for creating the tiny capacitors that manage the flow of electricity inside the phone's intricate circuitry. In Chile and Australia, vast open-pit mines yield copper, which is used for wiring and connectors, and lithium, the lightweight heart of the battery. From China, a host of rare earth elements like neodymium are sourced, which are vital for the magnets in the speakers and the Taptic engine that creates the subtle vibrations you feel. These materials are the fundamental building blocks, the Earth's contribution to the device. The aluminum that forms the iPhone's sleek, durable frame often begins its life as bauxite ore, mined in countries like Australia or Guinea. This ore is then shipped to smelters, often in places with cheap electricity like Iceland or China, where it's transformed through an energy-intensive process into the lightweight metal we recognize. The glass for the screen, a specialized and toughened material, is made from silica, which is essentially high-purity sand. The gold used in microscopic quantities for its excellent conductivity in the circuitry is sourced from mines all over the world. Each element has its own supply chain, its own history of extraction and refinement, creating a vast invisible network that underpins every single device. This global harvest of materials is the first and perhaps most overlooked chapter in the iPhone's life. It's a testament to modern logistics and a globalized economy. Ores are dug from the ground, separated and refined into usable metals and minerals. These purified materials are then sold and shipped to another set of factories, located in yet another group of countries. They arrive as powders, ingots and reels of wire, ready to be transformed from raw earth into the highly engineered components that will eventually come together. The journey from a rock in a distant mine to a polished component is a monumental feat of industrial coordination, setting the stage for the next phase of manufacturing. Once the raw materials are refined, they're sent to highly specialized factories across Asia and the world. Here, they're transformed into the sophisticated components that make an iPhone work. These are not Apple factories. They're facilities run by other global technology giants, each a master of its specific craft. The screen, your primary window into the digital world, is a marvel of engineering. Companies like Samsung and LG, both based in South Korea, are leading manufacturers of the vibrant OLED displays used in modern iPhones. These factories are incredibly clean environments, where layers of organic material are deposited on glass substrates with microscopic precision to create the millions of individual pixels that form the images you see. The brain of the iPhone, its powerful A-series chip, is another product of this distributed manufacturing model. The chip is designed by Apple's engineers in Cupertino, California. However, the actual fabrication is outsourced to a single, highly advanced manufacturer, Taiwan Semiconductor Manufacturing Company, or TSMC. Inside TSMC's massive foundries in Taiwan, Apple's designs are etched onto silicon wafers using a process called photolithography. This involves projecting incredibly complex circuit patterns onto the silicon, a process so precise it's measured in nanometers. Each wafer contains hundreds of chips, which are then cut out, tested, and packaged, ready to be installed on the iPhone's main logic board. Other critical parts come from a similar web of suppliers. The camera modules, with their sophisticated lenses and sensors, are a key selling point. Sony, a Japanese company, is the primary supplier of the advanced image sensors that capture the light for your photos and videos. These sensors are then assembled into complete camera modules by other companies like LG Innotek in South Korea and Foxconn in China, integrating lenses and stabilization mechanisms. The battery, which gives the device its life, is often manufactured by Chinese companies such as Sunwoda Electronic or Desay Battery Technology. Each component is a product of intense research and development, made in a factory optimized for one specific task. This ecosystem of suppliers is a delicate dance of competition and cooperation. Apple designs the product and sets exacting standards for quality and performance. It then leverages its immense scale to secure contracts with the best manufacturers in the world for each part. This strategy allows Apple to benefit from the specialized expertise and massive capital investments of companies like Samsung, TSMC, and Sony, without having to build and operate these incredibly expensive facilities itself. The components, the screen from Korea, the chip from Taiwan, the camera sensor from Japan, the battery from China, are all manufactured simultaneously, destined to meet on an assembly line for the final act. The culmination of this global effort happens in colossal factories primarily located in China. These facilities, run by contract manufacturers like Foxconn and Pegatron, are sprawling city-like campuses. The most famous of these is Foxconn's Longhua plant in Shenzhen, sometimes called iPhone City. It's here that the millions of individual components sourced from around the world finally converge. Trucks arrive daily, unloading pallets of screens, batteries, chips, and casings. These parts are cataloged and fed into a production system of immense scale and precision, a place where human labor and robotic automation work in a tightly choreographed ballet to build the final product from its constituent parts. Inside, the assembly lines stretch for what seems like miles. Tens of thousands of workers dressed in uniform smocks and caps perform specific, repetitive tasks. One worker might be responsible for placing the logic board into the chassis. The next might connect a tiny ribbon cable, another secures the battery in place. While much of the work is done by hand due to the need for human dexterity with small, delicate parts, automation is increasingly present. Robotic arms perform tasks that require immense precision or force, such as applying adhesive, polishing the enclosure, or driving screws with exact torque. This combination of human skill and robotic efficiency is what allows millions of devices to be built with remarkable consistency. The assembly process is a step-by-step construction. It begins with the empty aluminum or steel frame. The logic board, the central nervous system of the phone, is installed first. Then component after component is added: the Taptic engine, the speakers, the camera modules, and the complex array of antennas. Each step is followed by an automated check or a visual inspection to ensure the part is seated correctly and connected properly. The battery is one of the last major components to be installed before the screen is carefully sealed onto the body. The work is fast-paced and relentless, organized to maximize output while adhering to Apple's stringent quality control measures. Once the hardware is fully assembled, the phone is not yet complete. It's a body without a mind. The newly built devices move to a different station where the software is installed. Technicians connect the phones to racks that flash them with the latest version of iOS, bringing the hardware to life. Following the software installation, each device undergoes a battery of automated tests. Machines and software check everything from the cameras and microphones to the cellular and Wi-Fi radios and the touch sensitivity of the screen. Any device that fails a test is flagged and removed from the line for diagnosis and repair. Only the phones that pass every single test move on to the final stage: packaging. The final steps of the manufacturing journey transform the tested device into the product you see on a store shelf. In the packaging area of the assembly plant, the flawless iPhones that have passed all quality checks arrive for their last touches. A worker gives the device a final polish and places it carefully into the iconic minimalist white box. Other workers add the accessories, such as the charging cable and the small packet of documentation. An automated machine then wraps the box in a thin layer of clear plastic, sealing it for its long journey ahead. This moment is significant. It's the point where the collection of global components officially becomes a finished product, ready for a customer. From the factory floor, the packaged iPhones are loaded onto pallets and moved to nearby airports and shipping ports. Logistics teams work around the clock, especially during a new product launch, to coordinate a massive global airlift. Cargo planes are chartered to fly the devices directly from hubs in China, like Zhengzhou and Shenzhen, to distribution centers in key markets around the world, including the United States, Europe, and Japan. This rapid and expensive air freight operation ensures that millions of phones can be available in stores worldwide on the official launch day. It's a race against time, managed by complex software and a dedicated global supply chain team. For decades, China has been the undisputed center of iPhone assembly. The vast, skilled labor force, efficient infrastructure, and established ecosystem of component suppliers made it the ideal location for such a large-scale operation. However, in recent years, Apple has begun to diversify its manufacturing footprint. This strategic shift is driven by a desire to build more resilience into its supply chain and to access new markets. Factories in other countries are now playing an increasingly important role in the assembly of iPhones and other Apple products, signaling a slow but steady change in the geography of global electronics manufacturing. Today, while China remains the primary hub, a significant and growing number of iPhones are now assembled in India. Foxconn and other partners have established large facilities there, not just to serve the massive Indian market, but also to export devices globally. Similarly, Apple has a history of production in Brazil, primarily to navigate trade policies and serve the South American market. This diversification marks a new chapter in the iPhone story. The journey from raw materials to a finished device remains a testament to global interconnection, but the final assembly point is no longer confined to a single country. The story of how an iPhone is made is constantly evolving, just like the device itself.